Hey, welcome to our lecture on solutions. This is the start of a new chapter. We technically define a solution as a homogeneous mixture. And if you remember, homogeneous means it's got exactly the same composition throughout. So this would have to be a solution that is well stirred and well mixed to count. There are two components to a solution. There is a component that we call the solvent. And there's not a really great definition for solvent, but we typically take it as being the thing that is the largest component. So the individual things in a solution are called the components. So the solvent is the thing that you've got the most of. And everything else is referred to as the solute. So if there's more than one, then it's just solutes, right? If there's just one, it's a solute. And these are the smaller components. Now, what exactly do you mean by largest and smallest? Does it refer to mass? Does it refer to moles? Does it refer to something else? And the answer is mumble. So we're actually not going to say. So it turns out it's just a naming convention. So if you think it's mass, then you may get a slightly different answer than if you think it is moles. But in general, we just need some way to refer to stuff. So we're just going to use solvent for the big stuff and solute for everything else. In this course, we're often going to work with water as the solvent. And if water is the solvent, then we have a special name for a solution, if I can write. And that is, we refer to it as an aqueous solution. And in lab, right, and actually many times in this course, after a concentration or after a formula, we've written AQ to indicate that that thing is dissolved in water. So aqueous solutions just means the solvent is water. So let's take a look at some common solutions. So air is a solution, and a lot of people are like, well, solutions surely have to have liquids, right, in them somewhere. Liquids have to be the solvent. That's not true. So air is a homogeneous mixture, mainly of oxygen and nitrogen, about 21% oxygen, about 78% nitrogen, about 1% argon in dry air. And so this is an example of a gaseous solution. And if we look at something like club soda, so club soda is a typical kind of solution where it's liquidy, and it is essentially made of water as the prime component, so that would be the solvent, and some carbon dioxide gas dissolved in it to give it that kind of that fizzy flavor. And if we look at something like vodka, vodka is a solution of alcohol and water. Because vodka typically has 60% water and 40% ethanol, then water is the solvent and ethanol is the solute. So again, this is a liquid-liquid solution, whereas this was a gas-liquid and this was a gas-gas. So if we move on down, we can look at seawater, so brine. So that is a solution of salt of various kinds, sodium chloride, magnesium chloride, who knows what else, and water. And because we normally have more water than salt, right, I think that's pretty true of any seawater, then water would be the solvent and salt would be the solute. So that is a solid liquid solution. That's normally what most people think of as solutions. We can also have solid solutions. So these are often called alloys. So brass is an alloy of copper and zinc. And I'm not sure off the top of my head which is the biggest component. I believe copper. And if copper is the biggest component, then it would be the solvent and zinc would be the solute. So these solid solutions are what we call alloys.